We are going to prove the chain rule for derivatives. The chain rule. Okay. What is the statement of the chain rule? It says if f of x and g of x are both differentiable functions, then the derivative of phi of x is the derivative of f evaluated at g of x times the derivative of x. Now, before I prove this, I want to do something else. There are a lot of videos on YouTube which outright get this proof wrong. I'm going to go over that proof, or so-called proof, and show you where the error is. So, proof, but I'll cross it out. What they will say is the following. By definition, this is equal to the limit as h goes to 0 of f of g of, well, let's do it at x0. G of x0 times h plus h minus f of g of x0 all over h. And then they multiply by 1 in the following way, which I will show you in a moment. One moment, please. They multiply by g of x0 plus h minus g of x0, top and bottom. They multiply by g of x0 plus h minus g of x0 over itself. And they take their limit of the whole thing. And they say this is equal to the limit as h goes to 0. Using the little algebra, you could switch those two denominators, and you'll get f of, in the numerator, g of x0 plus h minus f of g of x0 all over g of x0 plus h minus g of x0 times this numerator, g of x0 plus h minus g of x0 all over h. And I'll skip some steps because this proof is invalid anyways. So you have a product here. So you can take the limit of the first factor and times that by the limit of the second factor. Well, the first factor is f prime of g of x, possibly, times the limit of the second one, which is f prime of g of x0 times g prime of x0. And the proof is done. But what I have in blue here doesn't have to equal 1. Okay? G of x0 plus h minus g of x0 divided by g of x0 plus h minus g of x0, well, in case the numerator is 0 and the bottom is 0, it's not 1. Okay, so when is the top 0? When is g of x0 plus h minus g of x0 equal to 0? Well, the instant I see the subtraction of two things equals 0, I immediately go, oh, those two things are equal to one another. Oh, g is a constant function. Not necessarily. That would work. If g is a constant function, then this theorem that this proof that I just gave you isn't valid for this constant function. But worse yet is the following. Suppose here is x0, and suppose around x0 you have an area around x0, a neighborhood around x0 where the g function is constant. It's constant. And it's differentiable, so after it being constant, I have to make sure that I don't put corner points like I just did. So you get the point. It leaves from the straight line in a nice fashion. Maybe like that. Okay, this function, g, this is the g function. This function is constant in here. Let's just assume that h is positive. Now, if this x right there is x0 plus delta, we have a problem. We have a problem when h is less than delta. The proof just blows up. Because remember, h is going to go to 0. So eventually, h will be less than delta. That is, x0 plus h will be contained in x0 comma x0 plus delta. This will be in there. Okay, so now when you find g of x plus h, g of x0 plus h, it will equal to g of x0. Because right here is the value of g of x0. But for all x's in here, for all x in, let's say the other side, well, for all x in x0 plus delta, g of x is equal to g of x0. And that means when you subtract them, you're guaranteed to have 0. There's no way around it. G of x, excuse me, g of x will equal g of x0 if x is in here. If x is in here. And if h is approaching 0 from the negative side, even if h is if this distance is h. Okay, x plus h. X plus h will be in that neighborhood, whether we call it x0 minus delta or x0 plus delta. It's probably better to call it. If x plus h is in there, we're in trouble. Okay, so this proof blows up. It's garbage. Don't think it works, and don't say, why is this guy making it so much harder when these proofs are trivial? Well, why? Because that trivial proof is not valid. Okay. So now, let's look at some things. We know that f prime of x is equal to this limit. Let's even call it 0. We know this. But what if we remove the fact that we're taking the limit as h goes to 0? Well, what happened then is this, the difference quotient, well, it's approximately the derivative. In fact, for h fairly small, it gives a good approximation. For h really big, you don't really know. It can be terrible. So if I want to make it equal, if I want this to equal to f prime of x0, I have to add something. And what I add is an error function. An error function. And the error is a function of h. You change h, the error changes. And since I'm going to be writing a lot of these error functions, let's just denote by putting a little f there that it was associated with their f function. Okay? Now, solving for this numerator, solving for the numerator here, that is, multiplying both sides by h, we're going to get this. And we're going to use this fact all over the place. This here is key. Okay. Now, I need to do the same thing for g. And there's the reason. So, we'll have g of x0 plus k minus f of minus g of x0, etc. This is k times g prime of x0 plus k times the error function of g, but it's in terms of k. Okay. And we're going to make two substitutions. I'm going to say let's use let y equal g of x0, and let k equal g of x0, the change in g of x0 plus h minus g of x0. Now, there's one last thing that I want to show. What is the limit of k as h goes to 0? Well, I can't find out the limit of just k, but maybe I can find out the limit of the other side. What is the limit as h goes to 0 of g of x0 plus h minus g of x0? Well, since g is differentiable, you can basically say h is 0. And you get g of x0 minus g of x0 is 0. That is, the limit as h goes to 0 of k is also 0. Okay. Armed with that, let us consider the proof. Let us look at the following. F of g, well, let me just write it slightly different. The fog of x0 plus h minus the fog of x0. Now if I divide it by h, that would be the difference quotient. We want to see what happens as h goes to 0. But let's just hold off on that. So this here is f of g of x. I just want to see one thing here. So over here, if you add y0 and k, you add these two, you're gonna get g of x0 plus h. Okay? So we have g of x0 plus h minus f of g of x0. Okay. Now, if you notice, x0 plus h, yeah, this is interesting. Don't know why it's coming up here, but let's just call this k. Now, I don't know what I am thinking, but x0 plus h, g of x0 plus h is y0 plus k. Okay, so this is f of y0 plus k minus g of x0. We said that's y0. But now I'm going to use my favorite formula. This here is my favorite formula. This says that this is equal to f prime of y0 times k plus, I'll put the k first, plus k times the error function, which is in terms of k, for the f function. Okay. Now, I'll say a couple of other things. One thing I'll say is y0 is also g of x0. And k, well, by definition, that was g of x0 plus h minus g of x0 plus k times the error. Okay. Favorite formula again. This is equal to f prime of g of x0 times that. That's g prime of x0 times h plus h times the error function. It's the error is with respect to the g function, and it's a function of h. K plus this. K error function of k. Okay. Now we're going to distribute. And I get f prime of g of x0 times, g prime of x0. Right there, that's what we want. Times h plus, plus we're distributing, plus f prime of g of x0 times h, error function for g of h, plus this constant, k times the error, ef of k. Now, let us look closely at what this equals. Well, just follow the equal signs. It equals this. I'd rather call it this than the line above. But it also equals the line above. It also equals the line above. In fact, I'll use the line above. So, we now know that fog of x0 plus h minus the fog function of x0 is equal to the line above. Now, since I'm not going to have space, I need to write this on 2 lines. So I might as well take more space. So this here equals the fog of x plus h minus the x0 plus h minus this, and that equal to the line above. Let me just bring that line down. This, I don't know why the rest didn't come. So, oh, I made a stupid mistake. Didn't want to bring it down exactly. Wanted to copy it. Okay, so they're going to want me to copy it in two pieces. Or I don't copy it. Let's see what's going to win out. So it equals this. Now, I'm going to divide this by h. So I have to divide this piece by h, and the h will cancel. I have to divide this piece by h, so the h will cancel. Now throughout this problem, h and k are not 0. Okay? Unlike the last proof or the non-proof, I can control h and k. I can say, hey, this h right here is not 0. It's going to approach 0, but it isn't 0. But when it came to that other proof, I couldn't control the h very well. Well, I couldn't control x0 plus h. Sometimes x0 plus h would be in a neighborhood where g of x0 plus h and g of x0 were equal. Okay, and I have to divide this one by h. Okay. Now, I run out of space on this board, so my goal is to take the limit of both sides. Okay, so let's copy this. Let's go to the next page. Let's get rid of one thing that I shouldn't have copied, and we'll move on. So let's see. When I take the limit as h goes to 0 of this, I will get the derivative of fog at x0. That I know. The limit as h goes to 0 of both sides. The limit of the left side is this, and it has to equal the limit of the right side. It has to equal to the limit as h goes to 0 of f prime of g of x0 times g prime of x0 plus this stuff. I'm going to write that in blue. Plus f prime of g of x0 times the error function of h for the g function plus k times the error function of k for the f function. So we need to take the limit of that sum. Well, for right now, or the three sums, for right now, I want to think of this as just one piece. So this is going to equal to the limit as h goes to 0 of the first term, f prime of g of x0 times g prime of x0 plus the limit as h goes to 0 of this, prime of g of x0, the error function, plus k times the error function. Okay. Now, if this limit was 0, then we're done. Okay, let me say that next step. This here is a constant. Even if it wasn't, with respect to h, it's a constant. I mean, x0 is a constant, g of x0 is a constant. You take g over value, you get a constant, and then the derivative of f at that constant is a constant, and g prime with x0 is a constant. You multiply constants, you get a constant. So we get f prime of g of x0 times g prime of x0. F prime of that. Plus its limit. F prime of g of x0 error of h for the g function plus k times the error of h. Now, we do have a typo somewhere. Okay? Remember, I was supposed to divide all of this by h, so that h cancel. I was supposed to divide this by h, and that h cancel, and I'm supposed to divide that by h. So, let me actually have that. Alright. Now I can say, if this limit right here equals 0, we're done. Because this equals this plus 0. Okay? So we just have to show that that last limit is 0. So what we have is, right now, we can say the following. The derivative of fog is equal to this. Equal to this. If and only if this limit is 0. The limit as h goes to 0 of f prime of g of x0 times the error function of h plus k times the error function of k over h. If and only if that equals, let me say it. If and only if that equals 0. Well, let's see if it is. Because if it is, we're done. Okay, so we have the limit of f prime of g of x0 times the error function of h for the g function plus k times the error function for the f function of k over h. We want to know if this limit is 0. Okay, it is a sum. So we'll take the limit separately. The limit as h goes to 0 of f prime of g of x0 times this error function plus the limit as h goes to 0 of this, which is k times this over that. Okay. Now both of these limits are products. It's this times that. I'll write it as the second one is this times that. So we have the limit as h goes to 0 of f prime of g of x0, which is a constant, times the limit as h goes to 0 of this, plus the limit as h goes to 0 of k over h times the limit as h goes to 0 of that. Okay, this is a constant. As h goes to 0, the constant couldn't care less times this limit. Well, we showed earlier that that's 0 plus this limit. Well, I'm going to think of k as, well, as how we defined it, namely that. And it says to divide it by h, okay, times this other limit, the limit as h goes to 0 of this. But you know what? I was careful at the beginning. I showed that when h goes to 0, k goes to 0. That is, I can change this to k goes to 0. Okay, well-defined times 0 is 0. Plus, this limit, g prime at x0, times this limit, that's 0. Ah, 0 plus 0, you know what? It equals 0. And that completes the proof of their chain rule. Thanks for watching.